All right, we're back at the night class. We're going to go over your chapter 7 review. Here we go. Suggestions. Change everything to what? Sine and cosine. So this cosecant becomes what? 1 over sine of x. That's the very first identity that's on your sheet. Secant is the reciprocal of 1 over cosine, so 1 over cosine x. Then you do math. You divide by a fraction, which means you flip and multiply. So times cosine x over 1 and cosine x over 1. And when you multiply those on the bottom, they go away, and you're left with cosine x over sine x. And from here, it's just a matter, do you want to change the cosine x over sine x to cotangent x, or do you want to change the cotangent x to cosine x over sine x? It's up to you. It doesn't really matter, okay? Just know you're not done proving your identity until you get both the exact same thing on both sides, okay? As soon as you get the exact same thing on both sides, you're finished when it says prove or when it says verify, all right? Everybody good on number 1? Mm-hmm. Awesome. Bless you. Number 2. Another verify. So 1, 2, 3, and 4 are all verified, and then we got some more at the bottom. So 2, verify that sine of x minus cosine of x squared equals 1 minus 2 sine of x cosine of x. Okay. So they're all sine and cosine, so that's checked. Okay, so the other suggestion is just to do math. So I'm going to multiply this left side out. Okay, I'll write it out first. You can skip this step if you know the shortcut. But if you don't know the shortcut, you might want to write it out. Okay, and then you multiply this out. So sine times sine is sine squared of x. Sine of x times negative cosine x is negative sine x cosine x. Have I blown anybody's mind yet? Everybody's good with that? All right. Negative cosine x times sine x is also negative sine x cosine x. And I just write those in that order so they match up with the other one I have. Okay, it doesn't, you can write them opposite, but it makes it's easier if they look alike, okay? And then you have negative cosine x times negative cosine x is positive cosine squared x. Okay? And then we simplify. This is the one that I told you probably need to memorize for ACT purposes and stuff, but what is sine squared x plus cosine squared x? What does that equal? That is 1. Okay, oops. 1, and then negative sine cosine x and negative sine cosine x make negative 2 sine x cosine x, which is what we want. And we're done. Okay. I tried even on the review to make them where they weren't too bad. Okay. I tried. Sometimes they just are. Everybody good on number 2? All right.
What do I use this for in real life?
You will use this when you take calculus.
I'm talking about
like once we graduate.
Outside of school.
Most of you probably won't. But there's a few engineers in here that mathematicians that it's a possibility.
Don't worry, that's me.
That's you?
That's me.
I figured.
Can you imagine, y'all? I would fail so fast.
Yeah, I'm gonna be a math professor.
There you go.
I'm gonna be an engineer. A mathematical engineer.
You're gonna engineer mathematics? Wow.
well, when you're broke because
That's the one.
You say that they do make mathematics all the time, so that is a thing. I was saying it jokingly, but they are. I don't know if they're specifically called mathematical engineers.
My brother is
but
an aerospace engineer.
that's awesome. There's like the people at Pixar that make all the movies, are, you know, they're making up math all the time. It's great. Look at us, Toy Story.
I mean, that's so bad.
Peace out, Woody. All right,
It's
3.
amazing for us, but it sucks to have to job.
Got another verify question. All right. Cosine squared x equals secant. Whoa, what is that? Minus tangent squared x minus sine squared x. Okay. It worked. Trying to figure out what number that is. So the suggestions were to change things to sine and cosine, but another suggestion was every time you see the squares, what do you need to concentrate on your formula sheet? Which group? The Pythagorean identities, 6, 7, and 8. Okay, so I want you to look at your Pythagorean identities, and there's one that deals with secant squared and tangent squared. It doesn't say this specific thing, but you can figure out what secant squared minus tangent squared would equal. It is number 8, and it is 1. So that would simplify to 1 minus sine squared, and we're still going to stick with the Pythagorean identities. Of your Pythagorean identities, what does 1 minus sine squared x equal? Cosine squared x, and we are done. Okay? But you got to be able to see what you need, okay? This is, and again, this is not the only way we could have done it, okay? The, right here, everybody got this way? Okay, this is why it makes them so hard to grade, and also why I'm trying to make your test a little easier, because it's just, we're going to do the same problem, get the same answer, everything's going to be right, but it's totally different way. So for this one, I could change just the secant squared x. Okay, the secant squared x says it's 1 plus tangent squared x, and then you just bring down your minus tangent squared x minus sine squared x, and these tangent squareds do what? Cancel, and I'm right back to equaling 1 minus sine squared x, which is cosine squared x. So that's a different way of doing the same problem, but it still gets it right. There's one extra problem, one extra step.
How is that switched to cosine?
Because sine squared x plus cosine squared x equals 1. So if you were to subtract sine squared x over, you get cosine squared x. So 1 minus sine squared is cosine squared. Okay? All right? Number 4. Another verifying, and then we get to take a break for a few problems. Let's see here. Cosine squared x times secant squared x minus 1 equals sine squared x, right? What are we going to try to change? The secant squared x minus 1. What would that be? Very good. Again, we're using our Pythagorean identities on that part. Okay. Now the suggestion would be to maybe change that to what? Sine over cosine, but it's not tangent, it's sine over cosine. So what do you think tangent squared is? Don't switch them. Keep them the same, just make them square. Okay. So this would just be sine squared x over cosine squared x times cosine squared x, and the cosine squared x do what? Cancel, because they're multiplying. One's on the top, one's on the bottom. You're left with sine squared x. Good. Okay. Library man?
Are we gonna miss our class?
Hope not.
We'll go to meeting tomorrow.
And what do I do? Okay, so
Have a lot of meetings.
there's 2 separate rooms you're supposed to go to. Okay, so I have dual credit Spanish 1, and I have dual They're both in separate rooms, so which room do I go to?
I wouldn't ask because I'm doing the same thing. And she told me to go in the library for the main study meeting and then she sent me and everybody else to the other lady.
Okay. Biology, Spanish,
Oh, no, no, same thing.
and computer.
Yeah, okay.
I'm being honest.
Hi, everybody good? Number 5. Carly, you can't hear me? Can you hear me?
Yes, I can hear you.
Okay, I got you. I was making sure. You were being quiet, so
Oh yeah, I muted myself.
gotcha. Okay. 5. It says to find the exact value of the cosine of 15. So, easiest way to do this is doing the sum and difference identities. We're still going to use the back of our cheat sheet where you have the chart, okay? You're looking for 2 angles on there that add up or subtract to be what? 15. So what would be 2 that add up to or subtract to be 15? 45 minus 30, right? So cosine of 45 degrees minus 30 degrees. And we look at the difference identity because we are subtracting for cosine. That will be cosine of 45, cosine of 30, plus the sine of 45 times the sine of 30. Okay? That's a fancy looking 5 right there. And then you use your chart or your fingers, whichever one you want to do. 45 is the middle finger. Cosine is the fingers to the left. So how many fingers are to the left? 2. So that will be square root of 2 over 2. The cosine of 30. 30 is the ring finger. How many fingers are to the left? 3. So square root of 3 over 2 plus sine of 45. Again, the middle finger. How many fingers to the right this time? 2. So square root of 2 over 2. And how many fingers to the right of your ring finger? Just your pinky. So square root of 1 over square root of 1 is what? 1. So that would just be 1/2. Okay? Or you can just use your chart, whichever way you want to do it. And then you just simplify it and you're done. So there's going to be a what on the bottom of both? 2 times 2 is 4. So they have a common denominator, which is 4. Square root of 2 times square root of 3 is square root of 6. Plus square root of 2 times 1 is square root of 2. Done. Okay? Everybody good?
It looks so easy when you do it.
I know.
Well, I'd be bad if I made it look hard. So it's kind of a good thing, but then it's kind of a bad thing too.
It's like you give me false confidence.
You're going to do great. Okay? You're going to do great.
I can't. I'm living off the high of the last 97.
Yeah, it was awesome.
Thank you.
Is Savannah coming over tonight?
I've practiced.
She got practice.
Which
Sorry.
means this is a big old F.
Yeah, sorry.
Above the line, Lord Kate.
Above the line, you're right.
6.
It's not common.
Yes. Cosine 105 degrees. What 2 numbers add or subtract to be 105? That's on your sheet there. Sir?
135 and 30. 150 and 45.
135 and 30. 150 and what? 45. You could even do 60 plus 45. Okay, so I want you to understand, no matter which one you pick, we'll all come out with the same answer. Okay? So I'm going to do the cosine of 45 plus 60. I encourage you to do one of the different ones, just so you can see that you should get the same answer. Okay? So if you want to do the what was it, 135 minus 30, go for it. If you want to do the 155 minus 1, I don't remember what you said now. 155, no, it wouldn't be. 160, no.
150 minus 40.
Thank you. 150 minus 45, go for it. Okay? I'm going to do the one where we're adding. So that'll be cosine of 45 degrees, cosine of 60 degrees, minus the sine of 45 degrees, and the sine of 60 degrees. And so that's going to be, if you look at your chart, square root of 2 over 2. That's 1 over 2, right? Yeah. Minus 45, again, square root of 2 over 2. And the sine of 60 is square root of 3 over 2. So you should get square root of 2 minus the square root of 6 over 4. Now, if you used one of the other ones, you might get the same thing, but then you might have negative square root of 6 plus square root of 2, okay? Which would be the same thing. Nate?
Yes.
Thank you.
Wait, so. Never mind.
You good?
I thought it cleared it up. Yeah, same thing.
Yeah, I was saying, the square root of 2 and the negative square root of 6 might be in different order if you pick different numbers. But it's the same, no, it's the same answer, okay? And also, don't forget, you can check it very easily. Put cosine of 105 in your calculator, get that big long decimal, then put your answer in the calculator and see if that big long decimal matches. Okay? So you'll at least know if you have it right or not. You got me? You may not have it simplified, but you'll know if you got it right. Everybody good on 6? All right, 7. Sine of 15. So basically, this is the same as number 5, but on number 5 we did cosine, and number 7 we're going to do sine. So I'm going to change it to the same thing, 45 minus 30. Ugh. And I'm going to do the difference identity for sine, which is sine of 45 degrees, cosine of 30 degrees, minus the cosine of 45 degrees times the sine of 30 degrees. And we look at our chart or use our finger, whichever way you want to do it. Sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2, and sine of 30 is 1/2. And one more time, we get square root of 6 minus the square root of 2 over 4. Okay. Everybody good with 7? Yes, sir. Yes.
I'm not right yet. That's
Sorry.
I don't know if I'm gonna pass without you.
Don't do what Haley's doing. Kaylee Goff, you were asleep.
I'm resting my eyes.
Yeah.
Her neck got tired.
That what it was? Got it, Madeline?
Yeah.
Awesome. Number 8. Tangent of 105. Remember, the tangent ones are the ugly ones because there's a lot more simplifying at the end, but I'm going to pick 40 and 45 and 60 again. If you don't want to, you don't have to. There are other numbers you can pick, but I like staying with the small ones. So I use the sum identity for tangent, which is number 13 if you're looking at your formula sheet, okay? And that's going to be the tangent of 45 plus the tangent of 60 divided by 1 minus the tangent of 45 times the tangent of 60. Make sure I got those right. And looks like I'm good. So what is the tangent of 45? It's 1, right?
Yeah.
You're making me doubt myself now. Yeah. And the tangent of 60 is square root of 3 divided by, so that's going to be 1 minus 1 times the square root of 3. So we get 1 plus square root of 3 over 1 minus the square root of 3, which would be wonderful, except we're not supposed to have that square root on the bottom. So we need to multiply by the what? Conjugate. Excellent. Excellent. What is the conjugate?
Something I'll never understand.
Not 1 minus square root of 3, but 1 plus square root of 3. On top and on the bottom. Okay? So the bottom, you get 1 times 1 is 1. Negative square root of 3 times positive square root of 3 is negative 3. On the top,
Wait, how did this not cancel?
what doesn't
It's
cancel?
like negative square root of 3 plus.
You're multiplying. You're saying negative square root of 3 times positive square root of 3. Okay? All right. So on top, you got 1 times 1 is 1. 1 times square root of 3 is square root of 3. Square root of 3 times 1 is square root of 3. And the square root of 3 times the square root of 3 is just 3. Add your like terms. 1 plus 3 is 4. Plus square root of 3 plus square root of 3 is 2 square root of 3 divided by what's on the bottom here? What kind of 2? Negative 2. And then for your last step, you just divide. What's 4 divided by negative 2? Negative 2. And then 2 divided by negative 2 is negative 1 square root of 3. So negative 2 minus the square root of 3. Everybody good? Sorry, everybody have it? Good. Are you singing Princess Carter?
I am.
Hey.
We were
Come out
listening
okay,
to it.
Yeah.
Okay.
The freaking, every time I try to get to the bathroom, it just study, I'm gonna clean all of them at the same time.
Gotcha.
Well, the one up there by the end is always closed. I had to go, I walked out, so just walked out the back home because they're mopping out. BBK.
What's up, Double B? All right. Number 9 is a verifying problem. So we're back to trying to get the same thing on one side as we do on the others. These, to me, are easier than even the first ones we did. Presley disagrees, and that's okay. She can disagree. Hopefully, I'm going to make you do this one since you disagree. Which one am I going to use? Which one am I doing? What are we doing? What is that? No, what is that? What is that? That's a minus. So we are subtracting, and we're doing what? Cosine. So we're going to do the difference identity for cosine. What is the difference identity for cosine? It's number, what, 10? 9 on your sheet? 9 or 10? So that's cosine of 270, cosine of theta, plus sine of 270. If you want to change it to x, you change it to x.
Change what
The theta.
Okay.
It's just a variable. I don't care what variable you pick. Okay? You want to change them to x, just make sure you change all of them. Okay? Don't like have x on one side and theta on the other. And then from here, it's just looking at our chart and plugging in. What's the cosine of 270? 0. 0 times the sine of, or excuse me, not times the sine of theta, but times the cosine of theta is going to be 0. So that's going to cancel. Plus the sine of 270 is -1 times the sine of theta. What is -1 times the sine of theta? Negative sine of theta. Like I said, I think that's a lot easier than the first 4 we did. It is. There's a lot going on. Number 10. It will hopefully be on YouTube as long as something doesn't malfunction. Yes. Remember last week I had some good videos and then they just would not upload. So I'm videoing my Zoom call, so maybe this works a little better. Let me know. Let me know how it goes. Number 10. We have verified that the sine of pi plus theta equals negative sine of theta. So, very similar, but this time we're adding, and we're going to use, everybody got had a little, just a little extra, a few more hours sleep over the weekend.
It's a manic Monday.
It's just another manic Monday. That's a good song. All right. Who sings that? Anyone?
Is that Blondie?
They're called the Bengals. Okay.
Yeah.
I was close.
I mean, you
Not the Beatles. The Beatles are insects. The Bengals are tigers. Okay.
You ought to be happy that we at least have
You did know the song. That's that was good. Yes.
Kind of like Banglemania, when Pink Floyd and all them came around, right? Bangles playing. And then
Pink Floyd and the Bengals would not be in the same genre.
never mind. There's Beatlemania, because when the Beatles came out, Pink Floyd and all them started making.
Gotcha. I got you.
Never mind.
Okay. So some identity for sine is sine of pi cosine of theta plus cosine of pi times the sine of theta. And then we look at our chart. Okay. Pi is 90 degrees. However, the chart says pi, so you don't really have to know that. What is the sine of pi? Everybody look at your chart and don't say no idea.
I did.
Pi is on there.
I don't see it.
Zero.
0.
It's 0
Whoa.
times cosine theta
0.
plus, what is the cosine of pi?
-1.
-1 times the sine of theta. And again, just like last time, 0 times cosine is 0. -1 times times sine is negative sine of theta. Boom.
How do you want us to write our answer?
Just like that. Yeah.
I got this last one.
So if we put our work on scratch paper, he wants to number it.
This is
Yes.
your,
Yes. This is the, yeah. Your work is your answer. So definitely number your work. Okay. Everybody good on 10? All right. 11. Now, I want you to understand on 11, we have already done 11. However, you can't cheat, okay? Everybody got 10? we're going to actually get a different answer, but it's going to be the same answer.
Well, that makes sense.
Doesn't it? It really does. Actually, you can get two different. It depends. We'll talk about it. All right. Tangent of 105. We have already done the tangent of 105 on number 8. Everybody see 8? Okay. Number 8, we use the sum identity for tangent. 11 says use the half angle identity for tangent. Okay, so they give us a specific identity to use, so we need to use the one they tell us. So to make this a half angle, I need to be dividing something by 2. So what do I do the 105? Not divide it by 2, but multiply it by 2, because I want it to still equal 105. Okay, so 210 divided by 2. And now I'm not going to use my sum and difference identities. I'm going to go to the middle at the top of my formula sheet and use the half angle identities. Okay. So first off, remember these can be plus or minus, right? Now remember that? How do I know which one it is? Where my quadrant is. Where is 105? Always go with the original. It's in the second quadrant. You got all star trig class. So tangent needs to be negative on this one. So it's negative square root, all right, of 1. Make sure I got it. Is it minus on top? Okay, so minus cosine of 210 divided by 1 plus the cosine of 210. Don't forget your negative out front of your square root. It's important. Okay? What is cosine of 210? Negative square root of 3 over 2. 1 plus the square root of 3 over 2. And here the daggum tangent again. It's always a little harder to simplify. So first I need to get one fraction on top and one fraction on bottom rather than having, I need to be able to add them. So in order to add these, I need a what? Common denominator. What's the common denominator? 2. So 1 would become what? 2 over 2. Okay, I'm just going to put it in red right here. 1 is 2 over 2. So I can now write that as one fraction. It's going to be 2 plus the square root of 3 over 2. Does everybody understand where I'm getting the plus? Negative times a negative is a positive. All right. Divided by, on the bottom, I did forget the negative here. Sorry about that. I did forget the negative there. So on the bottom, it'll be the same thing, but it'll be what? Minus. Okay, so 2 minus the square root of 3 over 2. Don't forget the little trick I showed you. What can we do with these 2's? Not multiply them. You're thinking of when you're dividing a fraction by a whole number. This is a fraction by a fraction. If the denominators are equal, they're just going to what? They're just going to cancel. Now you can flip it and multiply and see that, but they do. They just cancel. And so I have negative square root of 2 plus the square root of 3 divided by 2 minus the square root of 3. And it would be great if we could leave it like that, but they won't let us.
That's the radical.
Because of the radical, correct. The radical being on the bottom. So we need to multiply by the, what's it called again? Conjugate. What's the conjugate of 2 minus square root of 3? 2 plus square root of 3. Now, I am going to do it a little different on this one because we have a square root over everything. Okay? So you can multiply it out on top if you want to. We've already done it, actually. Okay? We've actually already done it. So I tell you what, I'll show you both ways and I'll show you how I would take both answers. Okay? So I'll do it like we did the other way a minute ago. Okay? So we multiplied the whole thing out. So 2 times 2 is what? 4 plus 2 times square root of 3 2 square root of 3. Square root of 3 times 2 would also be 2 square root of 3. And then square root of 3 times square root of 3 is 3. Divided by, on the bottom, we got 2 times 2. 2 times 2 is what? 4. And then negative square root of 3 times square root of 3 is negative 3. So we'll have negative square root. 4 plus 3 is 7. Plus 2 square root of 3 plus 2 square root of 3 is 4 square root of 3. And on the bottom, what's 4 minus 3? 1. And what's the square root of 1? 1. So there's my answer. Okay? The other answer I would have taken looks a little different, but if you put it in the calculator, it's the same thing. So I would take this, okay? Or you could have had up here, rather than multiplying this all out, what do you notice about them? They are the same. So you could write 2 plus the square root of 3 squared over 1, right? And then say, okay, negative, what's the square root of 2 plus square root of 3 squared?
2 plus square root of 3.
The square, yeah, the square root and the square go away. So you just have negative 2 plus square root of 3, and it's still over 1, okay? The only thing with doing it this way, you got to remember at the end, you got to distribute your negative, okay? So that's negative 2 minus the square root of 3. So I would take either of those answers. Even though they look different, if you type them in your calculator, you get the same big long decimal, okay? So if I'm not mistaken, the questions like this on your test are multiple choice. So you won't have that. I mean, they're not going to give you both of those for a choice, okay? So you'll just have to figure out what they did, all right? And again, push comes to shove, type the original one in the calculator, right? Type tangent of 105 in your calculator, see what the big long decimal is, and then just double check and make sure that the answer you're putting, if you put that in the calculator, is the same big long decimal.
You can do that for all of them?
Yes. Okay. Little ACT trick. Everybody good on, is that 12? 11, that's 11. Trying to
Everybody
go.
good except me? If so, I'll just get it.
You're great, Caden. Even though you missed my class tonight.
I know it.
You too.
Coach, I didn't mean to, I promise.
I miss y'all when you're not here, you know.
Hadley, do you even go to senior breakfast?
Missed out.
You gonna see your breakfast?
She's virtual.
Just said no. Don't make her feel any worse. You're horrible.
Are you even gonna walk with us at graduation?
She'll be there, right? You're gonna be at graduation, right?
Yeah.
Yeah, she'll be there.
It's in the evening though, so you might be able to make it.
Everybody good?
Hadley's gonna have to work nights. Anyway.
Hadley, what do you want to be when you grow up?
I don't know.
You don't know? I don't know either. I'm still trying to figure it out. I'll just keep doing this till I can figure out something, you know?
What would be another job you'd want to do other than
An engineer.
Like now, I don't know. I think I wish I would have went into like computers or something.
Coach Knight, I can see you as a weatherman.
A weatherman? It's going to be partly cloudy or partly sunny depending on your outlook in life. Here today, I mean, I never really understood that. What makes it partly cloudy or partly sunny?
Well, I mean, if there's some.
It's kind of the same thing, right? Exactly. Why did they say partly cloudy? They said, look, it's going to be partly, doesn't partly sunny sound like better?
No, I like clouds.
Partly sunny is above the line. Partly cloudy is below the line.
Well,
But I've never heard anybody say it's gonna be.
you know.
I haven't either, but they should.
Well, because it's naturally sunny.
Because the sun is a hole, the clouds are just hiding the sun, so it's part of the cloud.
I guess. Okay. Yes,
You
sir.
know who Alan Seals is?
Of course, the WKRG weatherman.
Yeah. Well, there's a whole Facebook page dedicated to memes of Alan Seals. And it's like the worse the weather gets, the nicer he gets. If you watch it, it'll be a beautiful day outside, and he'll be in like a short, like a polo shirt and khakis. And then Zeta's coming in, he's in a full suit.
That makes sense. I always thought, you remember Mel Showers? He was like the regular, he should have been a weatherman because his name, Mel Showers. You know, it just
Oh,
goes.
did y'all see where Alex
See,
Trebek
Coach
died?
Ryan.
Yeah, I did.
Dude on Jeopardy.
All right. I wanted to name my kids Day and
Oh, no.
I did it. No.
It's like Diana. Like Diana Knight.
Well, my wife's just, you know,
Well, it'd be Danielle and.
they would have day and night.
Yeah.
See? Anyway, all right.
That's a great idea.
Here we go. Let's change cotangent to what? What would be our first step?
1 over sine.
No.
So cotangent, I didn't know.
Cosine over sine. I forgot to put my x up there. Cosine of x over sine of x times sine squared x. This will, what happens here?
Oh, 1.
The bottom one goes away totally, and the top one, just the square goes away. So you're left with 2 cosine x sine x. And if you look, what do we call this when you're multiplying the angle by 2? Double angle identity. If you look at your double angle identity, down at the very bottom left, you will see that the sine of 2x equals 2 sine of x cosine of x. Now, these aren't written exactly the same, but are they the same? Yes. They are the same. So, sir?
With the change number.
I have a question.
Yes, Carly.
Okay, when you like canceled out the sine x and the 2,
Yes.
did you just cancel out 1 sine x?
Correct, because over here at sine squared is actually sine x times x, right?
Yeah.
Only one of those gets canceled, and you're left
Okay.
with the other one.
Okay.
Hey, could you say test 1, test 2?
Test 1, test 2.
Do it again.
Test 1, test 2.
Do it again.
Test 1, test 2.
There we go.
One more time.
Test 1, test 2.
Say Coach Knight is awesome.
Coach Knight is awesome.
Thank you. That was great. Awesome. 13. Half angle identity again. So 157.5. It says to make sure we use a half angle, so we need to double 157.5. What? 3. What is that? 330? What's 157.5 times 2, people? 315. I was way off. All right. So, again, what quadrant? All-star trig class. What quadrant's 157.5? It's in the second quadrant, so tangent is going to be negative square root again. So negative square root of 1 minus cosine of 315 divided by 1 plus the cosine of 315. What is the square root of 315? I look at my chart. Cosine of 315 is square root of 2 over 2. So again, we're gonna get these to be one fraction. So what do we change the 1 to? Again, 2 over 2. There and there. So this is gonna be 2 minus the square root of 2 over divided by 2 plus the square root of 2 over 2. The 2's on the bottom of each go bye-bye. They cancel. Left with negative 2 minus square root of 2 divided by 2 plus the square root of 2. Apparently I am standing in the way. Sorry.
I'll take your break. Use your break. You know how you know we get days in the senior year in our college.
Yeah.
You know how that's
You have and you have to call the college familiar company.
Do you have to bring proof back you were there?
Probably.
Like a brochure?
Yeah, this grass is from Mississippi State.
Yeah.
You can tell that because how it is.
They make good grass. They really do. All right. Next step is to multiply by the conjugate, which is this time 2 minus the square root of 2. So, which way y'all want to do it this time?
Well, we can do it the way where it's like.
You want to do it the square way or the way with the first way? Okay. So we're going to have negative square root. We'll have 4 minus 2 square root of 2 minus 2 square root of 2 plus 2. Square root of 2 times negative square root of 2 times negative square root of 2 is positive 2. Divided by, on the bottom, we just have 2 times 2 is 4. And then square root of 2 times negative square root of 2 is negative 2. So if you simplify all that, you get 6 minus 4 square root of 2 all over 2. And thankfully, those reduce, right? 6 divided by 2 is 3 last time I checked. And negative 4 divided by 2 is negative 2 square root of 2.
And if we did it the square way, would we get negative 4 minus square root of 2? Because I did it the way I want to make sure I'm right.
You would get the square way.
Yes, sir.
You would have gotten up here, let's see here, negative 2 minus square root of 2 over the square root of 2.
Yeah.
And then you would have to multiply, yeah. So that'd be negative 2 square root of 2 plus 2
Okay.
over 2, which would be negative square root of 2 plus 1. Yeah.
Okay.
So that could have been one answer. That could have been one answer as well. Everybody good?
Oh, why?
All right, 14.
Yes, sir.
Phew. It's going to be a good problem. 14 says verify that 1 plus the cosine of 2 theta divided by 2 cosine theta equals cosine theta. All right. So we have a double angle identity right here. Okay. We have 3 to choose from. One of the ones we have to choose from has just cosines in it, one has just sines in it, and one has a combination of sine and cosine. Look at the rest of the problem. There's only what? Cosine. So we're going to use the one that has just the cosine in it. And that says that 2 cosine squared x minus 1, or theta minus 1, divided by 2 cosine of theta. And lots of stuff cancels here, and just, it's kind of like a cancel spree. What's 1 minus 1? 0. They cancel. 2 divided by 2 is 1. Cancels. Cosine squared over cosine. Cosine cancels and the square cancels, and you're left with cosine of theta, or x. Bada boom, bada bing. Okay? Is it bada bing, bada boom?
Yeah.
My bad. It's opposite day. 15. The clock is against us. All right. The last 6 you are solving. Okay? The last 6 you are solving. These actually are pretty quick. 5 tangent of x equals 5 square root of 3. What do we do to solve this? First step. Divide by 5. So tangent of x will equal square root of 3. You look at your chart and the directions. The directions say 0 is less than or equal to x, which is less than or equal to 180. So you're only using the top half of your chart. Okay? So where is tangent of x square root of 3? Anywhere else? No. So x equals 60 degrees.
How about 2? Oh, yeah, 240.
240 is greater than 180. Okay? 16. Same process. A little more to it this time. 2 minus 3 cosine of x equals 5 plus 3 cosine of x. So we're going to get the cosines together and the numbers together. So I'm going to subtract 3 cosine x from both sides. Okay, that'll give me negative 6 cosine x equals, I'm going to subtract the 2 over to the other side. 5 minus 2 is 3. Everybody understand those first 2 steps? Now I divide by negative 6. And we're looking for where is cosine of x equal to negative 1/2. Again, we're going from 0 to 180. So cosine negative 1/2, I am seeing 120 degrees.
Hold on. No, to cancel out the negative. Never mind. Don't mind it.
It really is definitely close.
Everybody good? All right, 17. Tan of x, secant of x minus 2 tan of x equals 0. Now notice for this one, it wants to know all of them. Okay, so we're using the whole chart on this one, from 0 to 360. Everybody good? Okay. So what do I do? Starts with an F. Factor. What can I factor out? Tangent of x. Okay. So tangent of x, secant x minus 2 equals 0. Everybody see how I got secant x minus 2 left? I took out tangent of x and I divided both things by tangent of x. Those cancel, you're left with secant x minus 2. So tangent x equals 0. You set them both equal to 0. Secant of x will equal to 2. So on the first one, you're looking where everywhere on your chart where tangent of x is 0. So that's 0, 180, and 360. And you're also looking everywhere secant of x is 2. That would be 60 degrees, and 300 degrees.
Is wood subject to it?
Yeah, it's just getting a little scratchy.
It's just some water.
Dude. Oh. The rest will be online. I'm going to pause it. All right, 18. 18 is very similar to ones we just did. We need to do something again that starts with an F. What is this called? What are they? Factor. What do they have in common? Sine x. So I'm going to take that sine x out. And I will have left, if I divide both of these by sine of x, I'll have 1 plus 2 cosine x left equals 0. And so I set both of those equal to 0, and I'll get sine of x equals 0, and 2 cosine of x equals -1. I went ahead and moved the 1. Is everybody with me there? Okay. My sine of x one is ready, but the 2 cosine x I need to divide by what? 2. Divide by 2. So I'm looking on my chart everywhere. Let me make sure the directions, well, I just painted my directions say for 18, just from 0 to 180. So you're just looking at the top half of your chart, okay? So where is x, sine of x equal to 0 on the top half? 0 and 180. And then where is cosine -1/2? Anywhere? 120. So those are your answers. Again, just those because it just says from 0 to 180. Some of them say use all of them, and some of them say from 0 to 180. Okay?
Wait, so I was trying to pull my chart out for doing that. So to use 0. What did you do again?
I found where is sine 0. And it's 0 at 0, and it's 0 at 180. See what I'm saying? And then I said, where is cosine of x -1/2? And it was -1/2 at 120. Okay. All right, good and got those?
Can you hold on for like 3 seconds?
1,
While I'm talking?
2.
It's in your hand.
It's in your hand.
Wow.
It's always the last place you look, you know?
Don't be
Candy only got an hour of sleep last night.
She's all good in her hand first.
Yes, ma'am. I mean, you're the homeowner. I'm not. So I mean, I'm impressed. I really am. I'm very proud of you. No. She owns a house
Like with your own money?
with her own money. How cool is that?
Can I help you renovate? That just sounds like something I like.
No,
Help renovate.
she already has a renovator.
Yeah.
Wait,
You
you,
have a house for
it's me.
It's,
How do you have a house?
she
She
bought it.
she was 16. Tell me you don't feel super underaccomplished.
How really good?
All right,
If I
stay with me real quick. We'll talk about her house. 19. Same process. Oops. I forgot the equal 0 part. Sorry. What can we take out of this one? Cotangent x. When I take that out, that will be 1 plus 2 sine x.
That's really strong.
So cotangent x equals 0, and 2 sine of x will equal -1. I can right now. So we're looking for where the cotangent of x equals 0 and where the sine of x equals -1/2 between 0 and 180. Okay? Between 0 and 180.
Undefined.
90?
Cotangent
Yeah.
of x is 0 at
90?
Wait,
90.
Oh, 0. I'm sorry.
So 90 degrees, yes ma'am. And where is sine of x -1/2?
It's not.
It's not, so it's just 90 degrees is the only one. There would be an x if we were going from 0 to 360, but we're not going from 0 to 360 on this, okay? We do go from 0 to 360 on the last one, however. Okay? It doesn't say, it just says all real, but we're going to say, let's go from 0 to 3/16. Okay? Everybody good on 19? We're going to go back to it. All right, last one. 20. First step is what?
Add 3.
Add 3. Four cosine squared x equals 3. What next? Divide by 4. Cosine squared of x equals 3/4. And my last step.
Inverse. The inverse, the cosine.
Take the square root. Cosine squared. To get rid of square, you take square root. Okay? And then you try. Well, you can use your inverse too, but we're using our
Oh,
chart.
yeah, I got it, it's changed.
Okay, yeah. So you just take your square root. This will be the cosine of x. It is highly, highly important that you forget when you put these answers over here, you put what?
Plus or minus.
Plus or minus, okay? So it's plus or minus the square root of 3 divided by, what's the square root of 4? 2. So we are basically looking on our chart for where x, or the cosine of x, is either positive square root of 3/2 or negative square root of 3/2. So everywhere it's positive or negative square root of 3/2.
So like 30 and 150.
So like 30 and 150.
210 and 330.
I don't know what just happened.
I'm confused.
Where did it go, George?
Can you click the redo button?
There it is.
Where's Cosine?
Is that what it was?
That's kind of what I was
All right. That will conclude our video. Hope you learned something. Study hard, stay above the line, and we will see you next time.